So Unit 7 is all about three-dimensional figures and their attributes. The main attribute being the volume of a three-dimensional figure, which is how much space the object takes up in the world, right? Or you can fill it up. So that's a huge attribute that we talk about with three-dimensional figures. Another attribute is the height of the three-dimensional figure. So from the apex or top of this pyramid straight down to the base, how tall is this three-dimensional object? Or if you have a prism, the height of your prism is the distance between your two bases. This is a triangular prism. It has two bases. They're triangles. So the height of the prism is the distance between those two bases, right? So we have volume, height. Then the third attribute that we've talked about a lot is the area of the base. And so it's really important to be able to identify your base, be it a triangle or a rectangle. Find the area of that two-dimensional figure and then multiply it by the height of the three-dimensional object to get the whole volume. And so we've learned about those attributes, and we've manipulated the equation and found relationships between pyramids and prisms. So today we're going to be talking more about like situations in which we have a 3D object and it changes. And we're going to, the volume changes. And so we have the original volume, we find the new volume, and then we're going to find, well, by how much did it change? Okay, so there's a couple of steps involved in this, right? Because you have to determine the original volume, determine the new volume, and then find the amount of difference. Because change means difference. And so mathematically, the way that we find the difference in things is we subtract. So we'll be finding the two volumes and then subtracting. So this is pretty heavy in like reading comprehension, being able to visualize the situation. So we'll just take it step by step and see if we can understand the story that's being told. So let's go ahead with the first problem. SpongeBob is in the shape of a rectangular prism. He starts in the water with a volume of 240 cubic centimeters. After going for a walk on land, his dimensions are 5 centimeters by 6 centimeters by 2 centimeters. What is the change in volume? All right, so we have SpongeBob. We all know he's a sponge, right? And he's in water. Oh, okay, well, let me slow down. SpongeBob is in the shape of a rectangular prism. Okay, so he has two bases. And the bases are in the shape of a rectangle. Oh, kind of like this cube. That's a rectangular prism. Okay, so I can visually imagine what SpongeBob looks like. He starts in the water with a volume of 240 cubic centimeters. Oh, so he's in the water, completely absorbed in water, and his volume is 240 cubic centimeters. After going for a walk on land, so the sponge is no longer in water. I wonder how that's going to affect him. His dimensions are 5 centimeters by 6 centimeters by 2 centimeters. If he was in water and then went on land and dried up, I'm thinking that his sponge got smaller because it dried up, but we'll find out, right? So, and then we're wondering, what is the change in volume? It's very important to pay attention to what the question is asking. This question is not asking, what is the new volume? This question is asking, what is the change in volume? Okay, so we already have the original volume, 240. We need to find the new volume, and then we're going to find out how much it changed. All right, so I have a game plan. I'm just going to make a quick note. I'm already given the volume for the first situation for his starting volume, so I don't have to deal with anything with that. I'm just going to make a note so I remember, okay, the original volume right? It's 240 cubic centimeters. Okay. Okay. So now we need to determine the new volume. And I'll go ahead and write that over here. We have new volume we're looking for. Let's stop cooking. New volume. Okay. So I'm going to look for the new volume. Well, I know it's a rectangular prism. I have to figure out the volume. I have these three numbers, but I need to go to my star chart to figure out what to do with those three numbers, right? So I'm looking for volume of a prism is area of my base times my height, right? Okay. So the volume of a prism is area of my base times my height. Okay, we've done this a few times. My base is a rectangle, right? I know that because of the name of my figure here, rectangular prism. So to find the area of a rectangle, I just want to make sure I know exactly what it is. So I'm going to my star chart, area of a rectangle. How do I find the area of that rectangle? Oh, it's just base times height. Okay, that's what I thought. Just want to make sure. Okay, so the area of my rectangle is base times height. And then I surely would never forget to keep that height of my three-dimensional figure in my formula. So all I've done is rewritten my formula to show, okay, my area of my base is just a rectangle. This formula is telling me that according to GEMDOS, I need to find the area of my base first and then multiply it by the height of my three-dimensional object. And then I'll know the volume, right? I'm solving for volume. That's why it's V equals. Okay, so now I'm going to plug in. It doesn't identify like which is my base or my height, but you'll notice we're just multiplying all of them. So I'm just going to plug in 5 times 6 for my base, and then 2 for my height of my three-dimensional rectangular prism. Okay, so according to GEMDOS, I do grouping first, these brackets. Another way to think about it is with volume, we always want to find our area of our base first, right? And that's all this red stuff. So let's focus on the area of the base first. 5 times 6 is 30. Now all I have left to do is multiply it by 2. Okay, so you'll notice if you use the formula and plug in, it'll tell you what you have to do next so that you don't miss a step. Volume is 30 times 2, which is 60. So our new volume is 60 cubic centimeters. All right, my new volume is 60 cubic centimeters. Done. That's what I'm looking for, right? Wrong. Please, when you think you're done, go back to the question. Make sure you're answering the question that's being asked. It's not saying what is the new volume. It says what is the change in volume. Oh. So the original volume is 240. My new volume is 60. How much change took place? We have to figure that out. Well, mathematically, we find the amount of change by subtracting. So I will put that here, change. We're going to have to subtract 240, just black, 240 minus the new amount, 60. 0 minus 0 is 0. Oh, 4 minus 6, can't do that, have to borrow. That 2 becomes a 1, my 4 becomes 14. 14 minus 6 is 8. 1 minus 0 is 1. Okay. So the amount of change is 180 cubic centimeters. That is how much it has changed. Wow, let's think about that number for a second. It started off at 240 cubic centimeters. He shrank down to 60 cubic centimeters. So when he's out in the sun, that really dried him up, made him super small. We need to get him in some water because he's itty bitty. The amount of change is 180 cubic centimeters. It's a lot of change. So again, it's very much reading comprehension. What is the information I've been given, and what am I looking for? A lot of people stop right here in the problem and think they're done. Oh, my answer is 60 cubic centimeters. Okay, you'll get it wrong if you do it that way. You have to make sure I'm looking for the change. What do I do with that word? And that means you subtract. Change, difference, you have to subtract in math. All right.